Hello calculus students, welcome to the continuing series of videos on optimization problems. And in this here we are going to look at a couple more problems. And this time, before we dive in, we should talk about the general problem solving process, the general strategies for dealing with these problems. Because every problem is different, and if you try to remember some specific algorithm, you're going to go a little bit crazy. Okay, so let's think about what we did here in the previous problem. Look back on it and how we can extend it. Okay, so one of the things that you need to do is ask yourself when you deal with this problem, what is the independent variable? And this is very old-fashioned, going back to probably algebra 1. What is the dependent variable? Okay. Ask yourself those two questions, and then write a function that relates the two variables. Okay. This is probably the key part. And I should also add another note here. You might have a function that has lots of variables, but you basically want to eliminate algebraically any other variables. So we basically want to get this down to a function of a function of one variable. The function is the dependent one. The variable that you're using is the independent one, and then you're gonna eliminate any other variables. Then finally use calculus, not your calculator, to find min, max, or whatever it is that you're asked to find. Okay. So I'm going to show you a little bit how to set it up in this problem, and we'll talk about how to attack it. Determine the area of the largest isosceles triangle that can be inscribed in a circle with a radius of 5. Okay, so we start with a nice solid picture. This is my perfectly drawn or imperfectly drawn circle with an isosceles triangle inside of it, and we can figure that this radius here is going to equal to 5. And we want to somehow figure out what is the largest isosceles triangle that can be drawn in this. And I should say, largest means largest area. So this is a bit of a tricky problem because it doesn't ask specifically for what the independent variable is, but we know that the dependent variable here is the area of the circle. This is the area of the triangle. The area of the triangle. Okay. This is the item that we want to maximize. Okay. And now really we have a choice. We got to think and ask ourselves, like, what is it that we get to choose? How do we go about deciding where to draw a triangle inside of a circle? What factors are there that go into this? Just like in the previous problem, the decision that we were trying to make is where on the shore should we run to. Okay, so that's how we got this D here as our independent variable. So over here, you got to ask, what decision are you going to make? What input do you get to make in order to decide how this triangle is drawn? With certain constraints, the radius has to be 5, and the triangle itself must be isosceles. Okay. Well, one thing that we can try and point out here is that we can just label some things here. We can label this length L, and we can label this length L, and maybe we can label, and maybe you can say that, well, we can decide and use to draw the triangle based on how long this is in order to pick a length L and then use that to draw it in. But we can also pick this length here. Because this is an isosceles triangle, if you pick a point, if you pick a length like, say, X here, you know that this length over here is also X because the triangle is symmetric. So you can try and think of it, well, how do I pick the length of X here such that this triangle is at its largest? So maybe let me show you what I mean. So let's say I have a circle, and I have a center, and one thing I can do is I can either pick an X that's about this long. In other words, the other half of it has to be equally long, and then that would also define these two lengths here. Okay, and the reason for that is that if you draw a line straight down the middle, bisecting these two angles, it's going to be guaranteed to go through the center. Okay, this is a fact of geometry. Hopefully your geometry teacher taught you well. So instead of drawing this line so short, I could also draw a much longer line up here, a longer version of X, and then in which case I would have to pick this one and this, and these two lines would also be defined. Okay, so I'm going to use X as my independent variable, and I'll show you why that is. Okay. So I'm going to say that A here is the area, and the area here is going to be equal to 1/2 the base times the height. Well, 1/2 of the base is just X, and the height here is the radius, which is 5. Okay. That's this length right here. Times whatever this little length is right here, or plus, I'm sorry, the height is 5 plus this length right here, but this length right here forms a nice little right triangle with this section and this section, which is also the radius. So this is plus the square root of 25 minus x squared. So now what we've done is we've written a function a of x. This is what I mean when I said independent variable and dependent variable. The independent variable is x, is this length, which we get to choose, and by choosing this length, we pretty much have locked in the area of this triangle. Now you can ask, well, why did I choose x and not choose L? Well, you could choose L, and we could choose L. So we could, another way is, is to relate A, the area, to L. Okay. But I think you might find that a little bit more challenging than the way that I've set it up here. It's not that it's wrong, and there is a way to do it, but it might be a little bit more complicated if you did it this way. If you try to go this way, you gotta turn the triangle on its side and ask, well, what's the base here would be L, and the height would be this length right here, and it's a little bit harder to find this length as it relates to the radius. Okay, and you might be thinking, well, how would I know that just from looking at this problem that I'm supposed to use x and not L? Well, you don't. You just do these problems. You try it. You run into a brick wall, and then you go back and you try it again. I have tried and struggled with this problem before, so I know that this is the way it is. Okay, so and this part right here, eliminate any other variables. Well, good thing that there is no other variable. We don't have any. Any other variables here except a and x. In other cases, you might have other ones which you will have to deal with. Okay, so now I will leave it to you to finish this problem. This will be your homework, is to finish this problem. And keep in mind, we are looking for a. We are not looking for x. Okay, but you will have to find x in order to find a. All right. All right, and I'll leave this to you as well to do it on your own entirely. Okay. You're not really ready, you don't really fully understand until you can finish this problem, and then also start and finish an entirely other one fully on your own. Okay, so we've kind of walked through the process. I've done everything for you here. I've done the hard part for you here, and I'm going to ask you to do everything here. Okay. Thank you for watching. Have a wonderful evening.